Hey everybody, we're going to do one more thing on this amp, and this is prompted by a message that I got from Don, I'm a junk collector, about making sure that this amp was actually biased properly, and got to thinking about it and realized that he's absolutely right. So if you remember in the previous video, I had my bias balanced out at 47 milliamps, and I called that good. And the issue that you have with that is if the tubes are running too hot, they're not going to last long. The other thing that I've realized after doing some research is that the bias adjustment on this amp is not a true bias adjustment, it's a balance. So basically all it lets you do is balance the two tubes. It doesn't really change the bias. It's really a fixed bias on this thing. So we're going to do something here to test here, and what we're going to do is, the first thing we'll check is the plate voltage. Now on this particular amp, the way you test the plate voltage is you go into the output tubes, you remove them, you connect your speaker load just to be safe, and we're going to go to pin 3 of the output tube and pin 8 right there. So pin 3 and pin 8. And this is going to give me the plate voltage, and that's going to be used in the calculation. I have my meter set to DC volts, and I'm going to power up the amp. And you're going to have to let this thing settle in for a second. It's probably going to go down a little bit here. Just going to let that settle in. So I'm going to call my my plate voltage 472 just to average it out. I'm also going to move these leads to the other tube just to be safe and make sure I'm doing this right. There's pin 8 and pin 3 right there. Let's see what we get on that tube. That one's a little lower, 471.6. It's still fluctuating. Let's move it back to the other tube and see if it's settled down there as well. $471.6. Okay, so we're going to call it 471.8. Okay? Let me turn the power off, and I'll show you what the next step is. Alright, so the next step here is we have to calculate what the milliamp setting should be. And there's a great website here. It's tedweber.com, and it's /Weber VST/tubes1/calcbias.htm. And what you do is, first thing you do is you go in here and you set it's a Class AB amp, we know that. And we know that my tubes are 6L6 GCs. And the plate voltage that we just measured is 471.6. And I'm going to calculate the bias. And it looks like we're getting 44.5 as the setting for our bias. Okay? Now if you remember, when I was doing this yesterday, I was coming up with 47.8. So we're actually a little bit high. So let's see what the next step is. I'll be right back. If you take a look at this chart for the 6L6 GCs, you'll see here it has a little table. And you'll see my plate voltage is 471, but we're going to go with 475. And you'll see that setting your bias to 44 milliamps is hot, 70% of the power of the tube. Mine's at 47, so I know mine's way too high. It has to be lowered. Kind of hard to see this with the green font, but 38 milliamps is 60% right there, and cool would be 32 milliamps. I don't want mine cool because I want it to be a little punchy. I don't want it to be hot either because the tubes won't last long. So on this particular amp, I'm going to shoot for 38 milliamps. Now in order to do that, I have to make a change, and I'll show you what that is. Alright, so where we are now is I've checked the readings on these resistors. These are the grid resistors. This is supposed to be 470 ohms, and there's one underneath there that's supposed to be 1.5K. Both of them are way out of tolerance. So I believe that if I replace these, my plate current is going to be lower, and when my plate current is lower, my tube should be in better position to be biased. We'll find out if that's true or not. So I've got my old Hacko out here, solder sucker, and I'm going to take those resistors out, and I'm going to replace them, and we'll see where we are. We'll measure the voltage again. Be right back. Okay, I've taken out the first 470 ohm resistor, and I've got it connected to my meter, and you'll see I'm at 524, and I believe these are 1 watt 10% resistors, which means it's about 10 ohms over where it needs to be. So that's a good sign. So I'm going to go ahead and remove the rest of them. Be back. So I have to show you the second one. I took that one out, and look where that one is, 546, way over. So wise move to replace these things. Looks like there may be some burn marks on that thing too. Alright, we'll continue. Now we're on to the 1.5K ones. Alright, I've tested the 1.5K resistors in there, and they're actually both good. This one's at 1486, the other one's at 1486 as well. And with a 10% tolerance, I think I'm going to leave those in place. I don't think there's any harm in doing that. I think they're right where they need to be. So I'm going to go ahead and reinstall those other resistors and see where we go. I really don't want to disturb the wiring in here too much, so that's why I'm not going to take those out. I know some of you are probably saying I should do it, but that's the plan. I'll be back. Okay, as you can see, the resistors have been replaced. There's one, and there's two. And we're going to flip it over and see what the plate voltage looks like. Let's do that. Okay, I've got my probe leads again in 3 and 8 over here. I've got my meter set to DC, and we're going to power this thing up. Let's see what we get. I'm going to give it a minute to bake here. Looks like we're all over the place a little bit here still. Actually a little higher than before. It looks like we're settling in around the same spot. Now let's throw the bias tester on there and see what we get. Right back. Okay, we've just put the tester on here, and we're going to let this thing warm up. And you'll see it's climbing. I'm expecting that this is going to come down a little bit when it warms up. Remember, we did this at 47 yesterday, but by changing those resistors, we've made some change here. Okay, so to prepare this thing to find out what the right resistor value is going to be to get this thing biased, I've unsoldered this bias resistor from the center lug of this balance pot. And what I'm going to do is I'm going to connect an alligator clip here and here. And I'm going to run the wire out here. You see I've got it already taped. And I'm going to run it to a decade box. So let's put this one here, right there. Make sure that's on securely. And then the other side, we're going to connect right here to the center lug. Just like that. Okay. So what we're going to do now is we're going to flip this over, and we're going to power it up, and we're going to see what it looks like on the decade box and see if we can figure out what value this resistor needs to be. It's currently 15. It's brown, green, and orange with silver tolerance. So let's flip it over and see what we get. Okay, so with the 15K bias resistor detached and connected through these alligator wires that I showed you, I've got it connected up through a decade box. So remember, our objective is to get 38 milliamps on this thing. So we're going to turn this thing on. I'm going to start with a total load of 20. Actually, let's go with a total load of 25. So we're going to turn the 10K switch up. Let's turn the amp on and see what happens. We got power. Let's see what happens when these tubes come up. So that's going to be a total of 25K resistance. So it looks like it's peaking out at around 30. Let's just give it another minute here to warm up. Yep. So I think we have a little too much resistance on here at the moment. Let's see what the balance looks like. We've got 30.6, 30.2. So that's close. Let's bring this to, let's go to 6K. So we're going to take that 10K down. You'll watch this jump up like that. All right. And we're going to go a 3, a 5, and a 1 is 6. That's 6 plus 15, obviously. 21. And that brings us to 36.4. 36.9. Not quite where I want it to be. I want it to be at 38. So let's dial this back down to 5. So we're going to turn off the 1K and go with the 2 and the 3. Alright, that's a total of 20K. Right on the money. 38.2. 39. So now it's just a question of adjusting this balance on here, which I showed you yesterday. So let's do that. I'm going to go for 38.8 and let's see what happens. That's a little low. I think 38.4 is going to be the ticket. Let's try 38.2. Right about there. So I now have these two tubes balanced at a 38.2 milliamp setting, which is perfect for those tubes. So remember, this is going to be set for 60% power dissipation. So, which basically means that these tubes are healthy now. They're not going to blow out prematurely, and we've got this thing biased pretty well at the moment. All right, let me flip it over and we'll wrap up. All right, that's it for this one. So I want to thank Don for making that suggestion. So now we have that amp exactly where he needed to be. This is Ron. Thanks.